Welcome back to Massetti's Math Movies, where it's cute to be a square. Today's lesson is section 5.4, HL. By the end of the lesson, you'll be able to prove triangles are congruent by using HL. We've learned lots of ways to prove that triangles are congruent. And the last one we're going to learn is HL, which stands for hypotenuse leg. Now, the only kind of triangle that has a hypotenuse is a right triangle. So it's very important that this only works for right triangles. So if there's a matching hypotenuse in a leg and that corresponds with another hypotenuse and leg, the triangles are congruent. So you have to check, are they right triangles? Is the hypotenuse the same? So remember, the hypotenuse is across from the right angle. Is the hypotenuse the same? And is the leg the same? B, C, those are the same. That makes the triangles congruent. So now we need to make a little note here because I want you to look. This looks like angle, and there's a side that's the same, and a side that's the same. This looks like angle, side, side. And we talked that you can't use angle, side, side. That doesn't work. So we need to adjust our little saying to help us remember this. So if you remember, our saying is, you can have sass, but you can't be an ass. Unless, right? Angle, side, side works when it's a right triangle. So our saying is going to be, you can have sass, but you can't be an ass unless you are right. So it's a geometry lesson and a life lesson there for you. And in that case, you're going to put HL. So this is something you should definitely write down and remember. In the space at the right, draw a right triangle with a hypotenuse RT. So RT is the hypotenuse. Remember, the hypotenuse is across from the right angle. And the leg is TG. So this must be G here, because this is a leg. Name the other leg. Well, the legs make the right angle. So the other leg must be RG. So leg, and that's the hypotenuse. Determine when to use HL. Is it possible to show HL? Remember, HL looks like angle, side, side, but it has a right angle in it. So let's see if that works here. I see a side that's the same. There's one side. Oh, and here's an angle that's the same. And here's another angle or side that's the same. Angle, side, side. Angle, side, side. Well, we don't write angle, side, side. We see that they are right triangles. Notice the side that they're sharing. They're sharing this side. That's the reflexive property. It equals itself. So we are going to use HL. You're not going to write angle, side, side. That never works. If it is a right triangle, though, you write HL. All right, so here we go. These are all the ways we've learned to prove that triangles are congruent. Triangles are congruent. These are all the ways we've learned. You definitely need to know these 5 ways. So it says, mark your picture. A, B, we use the congruence postulate. Okay, so I need to mark my picture with side, side, side. So AB is equal to DE. There's one side. Another side is AC is equal to DF. Notice I'm using a double tick mark instead of a single, so I differentiate. BC, we'll use a triple tick mark on that, is equal to EF. All right, now we're going to mark. So this is what side, side, side looks like. What does side, angle, side look like? Well, you've got a side, so I just marked this. Angle B is equal to angle E, and BC is equal to EF. This is what side, angle, side looks like. So I'm just taking these and marking them on my picture. I want you to mark your picture with this now. Feel free to pause the video so you can do that. Use the HL theorem. Use the information in the diagram to prove that triangle PRQ is congruent to triangle PRS. So what do we know? We know that PR is perpendicular to SQ. And that means perpendicular, okay, if you forgot, this is perpendicular. And perpendicular means right angles. So let's put another right angle in there. So we have to show that these two triangles are the same. Well, I see a side that's the same. I think that was given. And I see an angle that's the same. And they're sharing a side. All right, so it looks like angle side side to me, but we never use angle side side. But if you see that it's a right triangle, we can call this HL. So let's see here. We know these, how do we know these are right angles? Because perpendicular lines form right angles. Then it wants me to write the other given. Well, here was the given. Remember, reflexive means they're sharing something. It's the same in both triangles. Well, what are they sharing? It looks like shaving. What are they sharing? They're sharing PR. So I'm going to say PR is congruent to PR. And the last line is always what you're trying to prove. We're trying to prove that triangle PRQ is congruent to triangle PRS. And why? Well, it's not angle side side, because that's not allowed. But since it is a right triangle, we call it HL. In example 2, why are the first two steps of the proof necessary? Well, the first two steps establish that it's a right triangle. We have to show that the triangles are right if we want to use HL. So the only time we can use HL is with right triangles. Which step shows that the two hypotenuses are congruent? Well, let's see. Where do we talk about the hypotenuse? Well, the hypotenuse is PS and PQ. PS and PQ, that's right here. This is where we talk about the hypotenuse. And PR is where we talk about the leg. So step 3 is the hypotenuse. Step 4 is the leg. Step 3 is the hypotenuse, and step 4 was the leg. Decide whether the triangles are congruent. All right, well, I see an angle, and I see another angle, and then I see a side. Oh, they're also sharing a side too, so that's another S. It's like extra information. So this is angle, angle, side. We don't have to put that extra S on there. That's more than we need. All right, what about over here? Here's an angle. Here's a side. Oh, and they're sharing a side. This looks like angle, side, side. Well, we can't use angle, side, side unless this is a right triangle. Is this a right triangle? No, no it's not. So we can't use these. All right, so now if we were to write it down in words, let's see what angles do we have here. We've got angle, this angle here, angle CAB, and angle CAD. We also had D congruent to B, and DC congruent to BC. That's why we could use angle, angle, side, because we talked about two angles and a side. Over here, we had a side, GF and GH. We had an angle, and then they shared a side. Remember, that's called reflexive. But the angles aren't in between, so you can't use SAS. And there's no, right, side-side angle or angle side-side. That doesn't work. So this doesn't work, and it's not a right triangle, so that's why that was no. Prove the triangles are congruent. Well, let's see. I see an angle the same, and I see a side the same. Well, it doesn't seem like it's enough information, though. But if you notice, this is an equilateral triangle. If you remember, if it's equilateral, it also is equiangular. So now I have another angle the same. I have angle, side, angle now. And you could end up doing many things. You could do side, 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 but we're going to stick with angle, side, angle on this. So let's see, how did we know that ST was equal to WV? That was given. S was equal to V and T was equal to V. Well, that's given. They told us that. They showed that on the picture. Then it said UVW is equilateral because all the sides are the same. That's the definition of equilateral. Then how do we know that V and W are the same? Well, because if it's equilateral, it also has to be equiangular. All right, then we use our transitive property to show that those are the same. Remember, the last line is always what you're trying to prove. We're trying to prove that these two triangles are congruent. We are going to skip the follow-up and do the checkpoint. So your options here are all the ones we've learned: side, 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 angle, 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 side, HL, or no, they're not congruent. Go ahead and do that now. This is M Cubed signing out.